Hello, welcome to my channel Study to Success. In this video, I am going to solve question 1A and B, which are achieved level questions from 2018 paper, 2019, 2020 and 2021 papers. So let's get started. This is from complex numbers. So 2018 question 1A reads this. What is the remainder when 2x cubed minus 3x squared plus 4x plus 3 is divided by x minus 2? This is pretty common question which is based on remainder theorem. So let's see. So what is given is you have an expression, a cubic expression which has to be divided by x minus 2. So for that, what we have to do is you can just consider x minus 2 equal to 0 because it is divided. So hence, since there is no remainder, that means the remainder is 0. So over here, we have x equal to 2. So we have to consider this equation, what is given to us as 2x cubed minus 3x squared plus 4x plus 3. We have to substitute x in place of this because this is the function. So we have 2 in place of x, we have to substitute 2. So it is 2 times 2 cubed minus 3 times 2 squared plus 4 times 2 plus 3. So this is going to be 2 times 2 cubed is 8 minus 3 times 2 squared is 4 plus 4 times 2 plus 3. So this is 16 minus 12 plus 8 plus 3. So 16 minus 12 is 4. 8 plus 3 is 11. So therefore, the answer is 15. Right. Let's move to B. So here, it is, the question is if u is equal to m cis, that is cos I plus I sine theta. It's cos theta plus I sine theta. Pi by 3 plus v equal to m cubed cis 2 pi over 5. Find uv in polar form. It's already in polar form, so we have to just keep it in polar form itself. So they have given uv is what we are supposed to find, where u and v is specified. For that, we need to know one rule, which is z1 is equal to r1 cis theta 1, z2 is equal to r2 cis theta 2. So your u can be, this is r1 cis theta 1 and r2 cis theta 2. So this will be z2. So in that case, when we take the product, that is z1 z2 will be r1 r2 cis theta 1 plus theta 2. And we are supposed to use this rule for answering question B. So when we apply this rule, what do we get? uv is equal to r1 r2. We can see here we have r1 R1, R2. So in this case, it's going to be R1 is M and R2 is going to be M cubed. So M times M cubed cis theta 1 plus theta 2. Theta 1 is pi by 3 and theta 2 is 2 pi by 5. So UV is equal to, so M times M cube is going to be M to the power of 4 from the index rule. And then we have cis. So it's pi by 3 plus 2 pi by 5. If you take the LCM, lowest common multiple of 3 and 5 is 15, plus this also is going to be 15. So how many 3's go in 15? 5. So we write pi pi. And here how many 5's go in 15? It's 3. So it will be 2 times 3, which is 6 pi over here. Because of 2, we have to times that by 3. So hence we get 6 pi. So we have UV is equal to M to the power of 4 cis. Now we can add them. So we have 11 pi by 15. This will be the solution for this question. Okay. Let's move to 2019 paper. And the first question A is solve the equation x squared minus 4x plus 7 equal to 0. Give your solution in the form a plus or minus square root of bi, where a and b are rational numbers. And this is also a pretty common question, which is based on quadratic equation. So let's solve. We have x squared minus 4x plus 7 equal to 0. So this is of the form ax squared plus bx plus c equal to 0. So we have from this equation, a is 1, b will be minus 4, and c is plus 7. So we have a 1, b negative 4, and c is 7 for this equation. And we know the quadratic equation can be solved by using this formula, minus b plus or minus square root of b squared minus 4ac over 2a. So now I'll just plug in all those values, what I've listed over here. So we have minus b. So it's negative of negative 4 because b is negative 4, plus or minus square root of minus 4 squared minus 4 times a is 1, c is 7 over 2a. So we get x equal to 4 plus or minus square root of 16 minus 28 over 2, which can be written as x equal to 4 plus or minus square root of, you get negative 12 over 2. But we know that negative square root of negative 1 is I, that is complex, imaginary. So we have x equal to 4 plus or minus square root of 12i over 2, or we have x equal to 4 plus or minus 2 root 3, because 4 times 3 so is 12, and the square root of 4 is 2. So therefore, I have 2 root 3i over 2. So if you take 2 as a common factor, hence we get 2 times 2 plus or minus root 3i over 2. Excuse me. So we have 2 and 2 getting cancelled, and therefore I will just write the answer over here. We have the answer as 2 plus or minus root 3i. Okay, let's see the next question. We have, when the polynomial 2x cubed minus x squared minus 4x plus p is divided by x minus 3, the remainder is 38. Find the value of p. So again, we will use remainder theorem. So according to remainder theorem, we have x minus 3 equal to 0. So we have x equal to 3. So that means we have to replace x by 3 in the cubic function given here. We have 2x cubed minus x squared minus 4x plus p equal to 38, because there is a remainder 38. Now we will substitute 3 in place of x. So we have 54 minus 21 plus p equal to 38, or 54 minus 21 is 33 plus p equal to 38, or we can say p equal to 38 minus 33. Therefore, we have p equal to 5. And this is the solution for this question. Right. Let's look at 2020 now. If s equal to 2 plus 3i and t equal to 3 plus ki, find the value of k if st equal to 21 minus I. This is also a pretty common question. So we have s given as 2 plus 3i, and t, it's a product, isn't it? st. So we have to multiply these two. So 2 plus 3i, and then we have 3 plus ki equal to 21 minus I. So let's expand this. 2 times 3 is 6 plus 2 times ki is 2ki plus 3i times 3 is 9i plus 3i times ki is 3k I squared equal to 21 minus I. So we have 6 plus 2ki plus 9i minus 3k equal to 21 minus I. Why is it minus 3k? Because I we know is square root of minus 1. So I squared is minus 1 and hence we can write this as minus 3i. So grouping real terms and imaginary terms, I'll group them first. And here we have I times 2k plus 9 equal to 21 minus I. So equating the real and imaginary terms. Okay, so equating real and imaginary terms. What do we get? 6 minus 3k equal to 21. Minus 3k equal to 15. Over here we get 2k plus 9 equal to minus 1. Or we have 2k equal to negative 10. So k is 5, negative 5. Over here also we get k equal to negative 5. So that means, we could have used only one, either real or imaginary, but I showed you both. So only we have to find the value of k. So it's perfect. When we are equating real also, we are getting the same answer and imaginary also same. So only one is enough. Either equate real or imaginary, but I equated both. Okay. Next. Find the value or values of r such that the equation x squared plus 4rx plus r equal to 0 has only one solution. So this is important. They say only one solution. So it's a quadratic equation. We have x squared plus 4rx plus r equal to 0. And because it's only one solution, we have to only take the discriminant. So discriminant is b squared minus 4ac equal to 0. So here we have a equal to 1, b is 4r, and c is r. Why? Because the quadratic equation expressed will be ax squared plus bx plus c equal to 0. So we have a1, b, 4r, c, r. We'll substitute in this equation. B squared happens to be 4r squared minus 4 times a is 1, c is r equal to 0. So this is going to be 16r squared minus 4r equal to 0. So we might as well write this as 16r squared equal to 4r, and r gets cancelled because this is r squared. So squared and r gets cancelled. So we have 16r equal to 4, or we can say r is equal to 4 over 16. And if you simplify this, you get 1 over 4. this will be the solution. Or you can write even 0.25. Right. Let's look at 2021 paper. Given that W is D plus 5i, and Z is 3 minus 4i, find the value of D if WZ is equal to 38 minus 9i. So it's again the product. W is D plus 5i, Z 3 minus 4i equal to 38 minus 9i. This is going to be 3d minus 4id plus 15i minus 20i squared equal to 38 minus 9i. So we have 9d plus 20 again, because I is square root of minus 1 and I squared is minus 1. So we have this becomes plus 20 and then minus 4id plus 15i equal to 38 minus 9i. So again, we have to equating real terms and imaginary terms. So when we equate the real terms, we get 3d plus 20 equal to 38. So 3d equal to 38 minus 20, 3d equal to 18, or d is equal to 6. We should be getting the same answer when we equate the imaginary as well. I will do it over here. Minus 4d plus 15 equal to negative 9. So minus 4d equal to negative 24, or d is equal to 6. So the solution is correct. Next. Okay, we have an Eigen diagram question. If Z is equal to 2 plus 3i, show 26 over Z on the Eigen diagram. 26 over Z. Z is 2 plus 3i. So the denominator is a complex number. So we have to rationalize the denominator. So rationalizing the denominator means you have to take the conjugate of the denominator. So we have 2 minus 3i will be the conjugate. Multiply and divide the conjugate. So we get 26 times 2 is 52. 26 times 3 is 78. I divided by, and this is of the form a plus b times a minus b. So we know it is going to be, okay, I will just do that. So 2 times 2 is 4 minus 6i plus 6i minus 9i squared. So a plus b times a minus b is a squared minus b squared. See, these two terms get cancelled. We have in the numerator 52 minus 78i, whereas the denominator is 4 minus 9i squared. And by now you are familiar that, anyway, I'll write here again, I is square root of minus 1. So therefore this becomes plus 9. So 4 plus 9 is 13. So this will give us If you take 52 and minus 78 are divisible by 13. So if you take 13 as a common factor, 13 times 4 is 52 and 13 times 6 is 78 and 13. So we have 13 and 13 getting cancelled. We could have taken 26, but the thing is, we have to plot it on the Eigen diagram. So that is why I'm taking, anyway, we have the denominator as 13, so I want to get rid of that. We get 13 and 13 getting cancelled, and hence we have 4 minus 6i that has to be plotted on the Eigen diagram. So let's do that. 4 minus 6i. Real is 4 and imaginary is minus 6. So we have the coordinate as so this will be 4 minus 6i. It will be in the fourth quadrant, this point. But if you want, you can draw the line. You have to just show the point on the Eigen diagram. All right. So we have come to the end of this video. Hope you liked it. So please subscribe to my channel, share this video with your friends, and look forward for some more videos from my end, where I'm again going to solve some questions on from 2018 to 2021, all the merit questions from question 1A. So I have divided the questions into 3 parts as achieved, merit, and excellence. So one video I'm doing only achieved level questions for question 1A and question 1 from 2018 to 2021. Again, I will do only merit questions from 2018 to 21, then excellence questions from 2018 to 2021. This is all only from question 1. All right. Thank you for watching. See you in the next video.